Alright, so here we go. We're going to get started with the battery bank and inverter setup. I am going to wire the DC side starting with the BMS first. I'm going to notch that piece of wood a little bit for the blue cable to go through to the negative terminal. The other cables I need to can run underneath, but that one's got to kind of duck. So the one's going to the positive terminal, I can run underneath. And I'm actually going to adapt this black line for positive by wrapping tape around it to indicate it's the positive line. Got the inputs for the DC connected here so that I can lay the inverter back down. I'm going to get the AC inputs connected soon. I'm going to move back to the battery bank at this point. I did drill a hole to accept that blue wire going through in my wooden cover. So we're going to get this BMS set up now. Okay, so for this battery management system, I've got the Bluetooth dongle connected. This one does not have a push button to reset the battery management system or get it started up. I think I got to connect these two terminals to make that happen. Got the temperature sensor here. It's supposed to have a disconnect if the temperature is too low for charging. That's an important feature for lithium batteries, lithium iron phosphate. So I'm going to go ahead and connect the battery negative blue wire here to the negative battery terminal. I got to lift this up and put this one on top, and then the first I'm actually going to connect the balance leads here to the BMS. Okay, so balance leads connected, Bluetooth dongle and temperature sensor connected, battery negative and negative for the negative terminal balance lead are connected. It's important when you're connecting terminals to use the Allen key to offset the force you're providing on the nut. You don't want to drive that stud into the battery by accident, and it doesn't require a boatload of torque. So anyhow, the next thing here is to fire up the app, and hopefully I find this on Bluetooth. I believe I have to tap this to reset it. I have to tap this to that terminal to get this thing to power on. So we'll figure it out here. I'm going to try the app. I actually just realized that because these posts on the Smart Shunt are so thick, I had to widen the hole here on this BMS load side. So I've widened it so it'll fit the post. I'm going to throw an extra washer on top of it to make good contact. Well, actually, no, it has one, so we'll be good. Just got to clean that up a little bit, and then we'll be ready to attach the Smart Shunt. I have to get a load on this BMS before I can get the app to activate. Alright, so I've got the positive hooked up to the shutoff switch. I've got a little bit of a bus bar here, double thick copper right here. That is going to connect to the A&L fuse holder, and then from the A&L fuse holder we'll be able to connect the battery or the inverter DC side. So, but that's going to go to a bus bar first, actually. So it'll be A&L fuse holder, bus bar, and then the positive terminal block. So anyhow, I'm right now I slit this piece of plumbing pipe. I'm going to slide it over right here to protect this from abrading against this battery. I want to keep it secure, so I'll tape the end to keep it from sliding, and it'll be a protector for that positive to avoid being ruptured by the copper with vibration. Okay, so we've got that nicely protected with the hard plastic that I split open. I just taped it so it won't rotate, and then put an extra layer of tape on the outer casing. Can't hurt. So anyhow, the next step is to hook up this switch again to this end, and then we'll get the A&L fuse holder in place as well. Alright, so I've got that thing snapped back together. I'm going to screw it in place in the wall here, and then we'll add this fuse holder into the mix. Alright, so I've got the positive side protected like I showed you, going to a marine battery shutoff switch. I did this ahead of the fuse because you need to change the fuse, and you don't want current going to it when you're changing it. So I put the A&L fuse. This is a 250 amp fuse. I don't expect more than 100 amps of draw out of this battery pack most of the time. I'm We've got this going to the positive bus bar down here, locked down, screwed in place. I'm going to be putting the negative bus bar over this way so that positive sweeps over and negative sweeps over from the inverter. That way they're not going to touch. So anyhow, at this point I'm going to call it a night, and I'll likely pick this back up after Christmas. Alright, so I'm back at the bus. I'm getting this 150 amp breaker ready to join to the positive bus bar. This is a parallel breaker. It's DC. It's hydraulic and magnetic. This is manufactured by a company called Airpacks. It's not designed for this, but you apparently, if I understand correctly, seeking the advice of somebody who shall remain nameless, well, I have got some advice on this, but anyway, you basically have to join these two in parallel on each side, is what it looks like, and then you follow the directional flow in from the battery and out toward the load. So the bottom here is out and the top is in. I have crud, I've actually got these terminals reversed. Oops. I'm gonna have to switch the bus bars around. I've got them actually backwards, because I have a 5/16 hole in this one and a 3/4 hole in this one. So this one's gonna go up against the bus bar. So I'm gonna swap these bars around. Alright, so here this bus bar is in position. I've got that bolt there so that I can put the inverter cable on, the positive inverter cable. So this will basically kind of hang on the bus bar on the second terminal in, and it'll go off to the side a bit, and then the inverter cable will clamp onto here. The other holes are to mount this with some screws and some standoffs. I might make those out of wood with holes drilled. Got to think about it, but a couple of standoffs to fasten it to the wall, and I'm going to wrap this in red tape, these bus bars, to help protect from people touching them. So I'm back at the bus here. I've got this copper bus ready to go up against the A&L fuse. I've got the copper lug bus, and here what I've got is the DC breaker. This is the line side. The other side over here is the load side. That screw, or that bolt right there, is where the inverter is going to hook on. I've got these with spacers all coated in tape for mounting. I'll put a little bit of tape over the screw heads. The idea here is I want it to be safe to reach in and flip the breaker, although 48 volts, you know, marginal as far as shock hazard. I don't want to risk it. I also don't want anything bumping up against this and shorting out. I want to minimize the contact area. So anyway, right now I'm about to mount this against that 1/4 inch piece of wood that I screwed in place. I'm going to get this all secured, and then I'll be able to start working on the negative side and get the DC side of the inverter connected. I need to get that done so that I can wake up the battery management system on the battery bank with a load, and then hopefully everything comes together. After I get this tested, I'll be checking with multimeters. I'll be making sure that the breaker switches the power on and off, as well as the battery interrupt switch. So, and then these additional terminals will be where the solar charging connects, as well as DC systems. So, got some extra lugs there for that. I'm going to leave the cover on until I get to that part of it. So anyhow, I'm just about ready to put this positive side together. This is a 250 amp A&L fuse. Looks kind of tiny to me, but it does say 250 amps on it, so hopefully that is correct. Alright, so here we go. I actually had to trim a little bit off this bus so that I could get the fuse in and out easily. So that's good. I've got the bus bar in place. I'm going to add the cap back in. I did trim the bottom a little bit because of the thickness of my material. This is really designed for factory cables and not necessarily for DIY bus bars. So anyway, we'll get that back on, and it's a two-handed operation there. Get that back on, and then I'll be able to get started on the negative side. Alright, so we've got the negative bus bar in place, cabled up to the smart shunt, cabled over to the battery management system. This is the temperature sensor and power supply to the smart shunt. Then on the battery management system, this is a Bluetooth dongle. Shouldn't be down there. Got to pull it back up. And this is the temperature sensor for the battery management system. So what I need to do now is hook up the DC side of the inverter after checking voltages with the switches turned on and see where we're at as far as the installation goes. Hopefully I get the right voltages and we're ready to connect the inverter. Okay, so I'm running some multimeter tests. We're going to start from the battery side, the blue cable there. I'm going to touch the metal there to right here before the switch, see what our voltage is. Alright, so that reading was 54.1. I'll have to do the math and see what the average cell voltage is, divided by 16. Okay, so that 54.1 is an average of 3.38 per cell, which is still a good mid-level charge on the cells. So what I'm going to do now, I actually already did. I flipped the switch here and I tested from this side of the breaker over to the blue terminal there and still got 54.1. The next thing is I'm going to do here to flip this DC breaker into the on position, and I'll test from where the inverter is going to connect to it down here to the same spot, after which I'm going to test the overall resistance between that location and that one, just to make sure I don't have any high resistance connections. Should be almost negligible resistance. Alright, so now that I got the correct voltages where I was checking them, I'm actually going to get this Genetry solar inverter connected. First thing I'm going to do is shut off this battery shutoff. And after that, I'm going to wire in AC wiring on one side and DC on the other. And I'll leave the AC breaker off. I'm actually going to do a 120 volt AC. I had intended to do 240, but based on the way the inverter works, that's not gonna function. So this live connection here is going to get curled up and reserved for potential future use. And what I'm going to do is cover this in electrical tape with these wire nuts, roll it up and make sure it's not going to short against anything. So I'll label it as well. But we're going to put the AC into the inverter at 20 amps, 120 volts, because the max throughput for charging is only 25 amps anyway. And based on the size of the battery bank, it'll give a reasonable charge. If it was totally dead, it would take probably 14 hours, maybe upwards to 16 hours to totally charge the battery bank at 120 volts with using other appliances once in a while. So that to me is sufficient. So that's what we're going to do. What I'm doing right now is running a separate 20 amp 120 volt line to one of these breakers that'll go to the inverter, since I decided to feed it with 120 volts instead of 240. So I'm going to, like I said, leave that old 240 connection in spooled for future use. And what I'm going to do is, I've got a headlamp on, I'll be shutting the power off before I try to finally wire this in. Don't want to get shocked. Okay, so with this 10 gauge wire, I've added in a 20 amp 120 volt circuit here. This will feed the inverter, and at this point I should be able to get the inverter wired up. Right now I'm going to wire the AC lines to the Genetry inverter. We're going to have the 110 here. This is a 10 gauge. I'm hoping that the 6 gauge I chose for the output here is going to work. If not, I'm going to have to trim back the wires a little bit and put fewer strands in into the receptacle here. So looks like we've got indications here with arrows for in or out. And then load 1 and neutral, and then we tie the grounds in here. So, and right here it'll be the output of line 1, line 2, the neutral and ground. So I actually do have a fender washer to make the ground a little easier to connect. I'm just going to kind of spool the grounds together on this, or kind of spin them together and put some fender washers in to sandwich them. So that's the plan anyway. To make this a little bit easier, I very gently stood this on end on a rug to protect the connectors, so that the force was on the corner. Now I can see where I'm putting the wires in. I'm leaving quite a bit of slack so that I can get the inverter up out if I need to without disconnecting everything. Okay, so there's the AC side. We have the input, hot lead, the neutral, the ground, which goes to the chassis. Then we've got the hot lead, neutral, and second hot lead for the 240 with the ground also tied into the chassis. Now I'm going to slide that cover up and get it into this slot here, and then I'll use the 2 screws that they supplied to cover this up for safety. After that, I can connect the DC end, which is mostly already set up. I just got to loosen one of the connections, or maybe both, and get them adjusted for where I put the bus bars. And after that, I'll be able to screw the inverter to the floor. Alright, there we go. I've got the AC lines connected. The biggest you should go here is 8 gauge. This was a little bit overkill, and it was hard to connect the 6 gauge. This inverter is on a 30 amp breaker, so this is 1 wire gauge higher than it needed to be, as far as the output goes. So anyhow, it did work. It was just very difficult to get the casing in, made even more difficult by the little ground screw here. It's a little bit of a challenge to get the wires on it. I used a fender washer that I split so that it was not too long into the slot, and that kind of held the wires against the case. So that should work for the ground nicely. Now what I'm going to do is set the inverter down into the hole here and get the DC lugs connected. Back at the bus after New Year's, couple days away here, relaxing. I've got the 120 volt connection labeled here. I'm getting things clamped in place, kind of cleaning up the wires so they don't rattle around. Got them screwed into the wall here. So I'll probably put another one down there to kind of organize. And then we're going to get the inverter, figure out how the inverter is going to get put into position. And as a result of that, I've got to get these DC connections made kind of as I'm putting it in, which in these cramped quarters might be a little bit difficult. So I've got to figure that out as I go as well. I'm probably going to tip the inverter on its edge up into this lid a little bit so I have some working room on the DC side. I'll make sure all the power's off when I'm working on that with the battery interrupt switch. And the AC in is also off right now. I don't want to turn that on until I've got the inverter programmed. So, and I also need to make sure the BMS and the shunt are all wired up, because it would likely immediately start charging the batteries, and I don't know that the parameters, well, I know that the parameters aren't set on that yet, so for the management system. Alright, so right here I've adjusted these cables for the DC input so that I can have them coming up into the bus bars at the right angle, and made sure these were good and snug but not too tight. I don't want to break anything here. So anyhow, I am ready at this point to drop this in place and get it connected to the bus bars on this side, and then we'll wake up the BMS and I'll start programming things. Alright, so with just a little bit of clearance, I got the Genetry solar inverter. This is a 6,000 watt into the hole. It was kind of hard to get it around this. So I left a good bit of room here for the fans to blow and cool the unit. I'm going to need to likely add some holes, possibly even some holes through that wood there, although that is support structure. I've got to think a little bit about that, but I want the fans to blow, through the tops of the batteries as well, and have a place for the hot air to escape. There'll be some holes drilled behind me under the floor as well. So what I'm going to do now is get this woken up, and the hatch that I'm sitting on right now I'm going to raise to give myself some working room, and we'll get the bus bars connected to the leads here. After that's done, I'll get this thing screwed into place to the floor. Alright, so I've got the positive lead and the negative lead over here connected, and the next thing will be to screw this inverter down in the right spot. After that, I'm going to wake it up and power it on, and then we'll configure the BMS. The thing I'm going to mention here is these rubber-backed carpet pieces I cut are going to go under the metal here to hopefully just cushion the jarring effect of driving a little bit with this inverter. Instead of being a direct impact, it'll just kind of cushion it a bit. So we'll put those down before we screw it in place. Alright, so here we go. We got the inverter screwed down. I got 2 screws in each slot, carpet underneath, so total of 8 screws holding it down. It's going through that 3/4 ply down into the surface. The 3/4 ply is screwed in, so it shouldn't shift. And everything's tight. I'm at the point now where all I need to do is turn it on and connect the 2 sides of the BMS briefly to see if this wakes up and gets the voltage it requires. Make sure everything's turned on and we'll be good to go. I'll get to programming things, assuming everything is in good order. Alright, so if I use that copper wire to bypass the BMS terminal to terminal, just cut through it, I'm able to get the inverter to turn on just fine, but it won't stay on if I remove the wire. So the BMS is not waking up. I already measured the cell voltages on the pin right there on the white connector. They're all good. I'm wondering if the temperature sensor probe is either defective or not being recognized. I'm not sure. I may have to call Current Connected, who I bought that from, and see if they can help me figure out what's up. But it's Sunday, and I'd have to call them probably during a weekday. So anyway, that's about all I can do for now until I figure out why that BMS is not waking up. I know that other people have had challenges with it. I do not have a push button on the Bluetooth dongle, which I've seen in some videos wakes the BMS up. This one doesn't have that, so not entirely sure. And the Daly manual that I was able to download is pretty much in broken Chinese English, and it's hard to understand what the manufacturer has to say here. So hopefully I can get the resource I bought it from to help me. Okay, so right now I'm actually running power in the bus, the lights and stuff, off of the inverter. I'd imagine that copper wire might be getting a little bit warm, but yeah, so far the BMS is not woken up, so I don't know what's going on there. I'm going to go ahead and stop this load and power off the inverter. Well, I'm going to see first if the BMS can be recognized on Bluetooth really quick, and then if not, I'll try to get after killing the load and pulling the wire and see what we got. Alright, so the inverter's still not waking up. I'm not sure what the deal is. Like I said, I'll call on Monday, tomorrow, and see what they have to tell me. Okay, so I talked to Dexter from Current Connected. He has a nice YouTube video as well for this. That's the company I got it from originally a while back. So this is one of the older units. It didn't ship with a light board connector with a power switch. Alright, so I'm back at the bus here. I'm still waiting on the light board switch that'll hopefully make that thing behave. I'm really not happy with the Daly BMS. I think it's way too weird and complicated. Should just be able to push a switch on it or something to turn it on. But the thing's goofy as all get out. So anyway, I also am not happy that the balance leads are so short. I'm actually going to splice and extend those. I got another black battery cable for the negative side. I'm going to extend the blue cable so that I can put the BMS down in here in this space along with the shunt. So I'm going to take the stuff off, get things disconnected, and redo the balance leads. Okay, so I've detached the balance leads. I'm going to use some thicker cable here, cut that up in 2.5-foot pieces, and I'm going to extend these cables, which are way too short. So anyway, this will allow me to position on some wood platforms that I'm going to build, allow me to position the BMS and the smart shunt in between these two devices, just to make it a little bit easier to access the batteries for maintenance. So I just used my label maker to put some labels together for the balance leads. Got the negative, and then I've numbered all the positive leads up to 16. So right now I'm using my soldering rig with the balance lead here. Got some alligator clip holders and soldering iron and a little bit of fine solder. So I'm trying to create an extension on these of about 20 inches each, I guess, just to make the fit of the BMS better. So I'm going to continue soldering all these leads. So I've done a lineman splice, and then I'm just coating it with solder, and then I'll put shrink wrap over it. Once I've done them all, I'll get the heat gun out and put shrink wrap over them. After that, I'm going to put new ring terminal ends on this 16 gauge wire. It'll fit better. And then I'll shrink wrap those as well. Alright, so right there I've got that one tinned. Door just slammed. Anyway, I got that one tinned, and I'll keep moving on. Got about 17 of these to do in total. Okay, so I've soldered this 16 gauge to this really light stuff for the connector here, and now I'm going to shrink wrap it with the heat gun. Alright, so I've got all the terminals connected, soldered. Got the wire extensions soldered on. This is the negative lead, so I coated it in black tape. I'm going to now test continuity between the terminals and the pins on the connector here. Make sure everything's good to go. After which I'll take this in the bus and get things reinstalled in the way that I wanted it to be. Alright, so I've got this BMS balance lead all put together with extensions. I've got them labeled according to what terminal they go to. Next I'm going to connect them and check voltages, make sure everything's good to go. And hopefully, once I've got it all connected, I'll be able to install the BMS where I want it instead of the awkward position up top, because that was too short. So just cost me like about 3 or 4 hours or more of labor, so they could save a nickel on wire. So anyway, not real happy about the quality of the BMS wiring. You know, it's really thin, and you know, they only gave us like 2 feet of it. It was really ridiculous how short the lead was. So anyhow, is what it is. Got it hopefully solved here. So I've got all the balance leads connected. I've got the positive lead going back over to the fuse and the switch. Over here I've shielded the negative cable with some of that really thick vinyl. I've got it going over to the BMS, to the battery negative side. I'm screwing them together with a bolt. I'm going to wrap that in some electrical tape and maybe put some of the vinyl over that as well. Similarly, I'm going to coat these exposed conductors. I don't want any accidental sparking. So anyhow, I'm going to coat those, and then we'll put the kind of use some electrical tape to clean up the wires on top, get them fixed. I've already tested the voltages. All the voltages on the pins are good, so it's all coming together again. Okay, so I've got the balance leads kind of taped together so they're more organized and they're not going to flop around very much. And got it to where I can just connect this right up to the BMS. This will kind of sit next to the BMS or slightly over top of it. So, and then we'll hook that connector in. BMS is going to be on a platform right here that I've yet to build. And then the shunt will go right next to it. I'm not going to block the fan, which is about right here on the side of the inverter. Right in here. So we'll keep that space open for fan. But anyhow, I've got to build a little wooden platform. That's going to be the next time I come out. Hopefully pretty soon the light board switch comes for this. And I can get it to wake up. So it's been a process for sure. Alright, so every time I finish working, I do cover the battery bank and make sure nothing's going to spark. Very important to avoid a fire. I'm back at the bus here on a very cold evening. I actually got the light board switch received from Current Connected today. And hopefully when I connect all this stuff and push the button, this BMS will wake up and do its job. So anyhow, I'm going to get the negative cables wired back up and see where we're at. Alright, so I've got the BMS and the smart shunt connected to the negative bar. It's all ready to test here at this point, so I'm going to flip this and then we'll push the button and see if we wake this sucker up. And there we go. I flipped the little light board switch and we're in business. And I'm going to bet that the Bluetooth will recognize the unit now, and we can recognize the smart shunt over here as well. So happy.